Hi, everybody. Very happy to be here today. And as with many things, we are celebrating Cybersecurity Awareness Month. In honor of that, I'd like to give you a tip to protect your companies. It's important to isolate all your IoT devices from the rest of your servers. So whether you put them on another network or you isolate them in a network segmentation with its own firewall, these are best practices to protect you. As we know, these devices are doing machine-to-machine things. They are not always updated. They are not always reviewed by humans. And so having them isolated from your company jewels is a smart thing to do. Okay, so we're going to get started on the webinar for today, which is data breaches are inevitable. Are you prepared? There's a concept called zero trust. It's been out there for several years. I know I've been talking about it for at least 3, but it wasn't accepted, I don't think, by the industry until very recently. And now it seems as though everyone is using it. I believe John Kildervag was the first to coin the term when he was at Forrester. Today, the agenda, we're going to talk about why zero trust makes sense in today's world with cloud and the challenges that you get into with traditional application architectures. And then what is zero trust, and then how to use something called the software-defined perimeter to help implement the zero trust construct or posture, as we call it. So what are today's challenges? I think we're all aware that we're all working more and more remotely. In fact, I'm doing this webinar today from my home in Chicago. And at any minute, the dogs could bark. So I'm just going to warn you now. I don't think they will. They have been isolated onto another network, but I don't think they'll stay there. At any rate, so let's talk about what's happening in our world. More and more remote workers are, more and more workers are working outside their homes. I mean, working in their homes, outside their offices. There has been a 115% growth in the past decade, nearly 10 times faster than the rest of the workforce. And the impact of that is that they no longer live inside the 4 walls of our company. They're everywhere. They're working in coffee shops, and we all know this. The traditional remote access solutions that we've been using for this sort of thing, like a VPN and a firewall, fall a bit short in protecting us with remote workers, remote employees. I like to call the systems admins our God users. If they were to leave, then they become a risk to our company. All of the solutions that we're using today fall a bit short. That includes some modern NACs and things. But if you're going to protect your company from third-party users, from home keyers, from contractors and staff, and again, not that these folks are nefarious themselves. They might be lovely people, but their credentials could get stolen. So if you're going to do that, the idea is that the VPN and the firewall in and of themselves aren't enough anymore. The VPN itself is simply looking at an IP address, and we'll talk about that in just a moment. I don't know if you realize this, but network security and its tools haven't really changed in the last 20 years. And there's 2 reasons why this network security is not working. Number 1, TCP/IP is really a weak security foundation. Okay, we're automatically assuming that if you connect, you are trusted. And that's where the zero trust comes in. We can't trust anybody anymore because we don't really know that you are who you say you are when you're logging in. And since TCP/IP connects first and authenticates second, it's just not a good way in which to access important company assets. It has a poor policy language. I mean, frankly, this is very complex, and it requires a lot of programming to make it work in the way we need to. And companies are not willing to do that. And it's also black and white, yes or no. So why aren't VPNs working? They do not keep you really secure. They allow overprivileged folks to get on the network and then go off to the races to do whatever it is that they need to do and more. It's not really a security solution, it's a connectivity bridge. And even the SSL VPNs mean that you're connecting securely, but it doesn't mean that whoever connects is who they say they are. And adding encryption, of course, in the communication. It really doesn't help with the access. And then once you're authenticated, you have complete access to the authenticated network. So whatever is on there, we know the nefarious individuals will lie in wait. They will wait, and they will wait, and they're extremely patient. They will look laterally, and they will look for things like your financial systems or your HIPAA systems or anything that has information, personal identification information or financial information, whatever is that they can monetize. Gartner says that 60% of enterprises will phase out VPNs by 2021. So why isn't the firewall? Why isn't it working? Firewalls are still useful to us. I'm not advocating that you throw them out at all, but we have to understand their limitations and then work with other tools and processes to shore them up. So the key issues are that they are static. You configure them and then you forget. We also define everything in terms of ports and addresses, not users. We don't have a lot of contextual information that helps us to understand, oh, that user, that's Johnny, he shouldn't be in China. Why is he coming in from China? There's just no additional information to help us do a better job of protecting our assets. So once again, you have overprivileged users. We're letting everybody in, given some basic credentials. There's all kinds of exceptions because in order to do the work of the company, there's always exceptions that are built in. Every time you do something, there's another firewall rule. It's extremely difficult to manage. And it's really, the firewalls are not typically designed for cloud architectures. They're not designed to address specific users. Here's another example. Even if you prohibit external exposure of 3389, how many of you have used tools like TeamViewer or LogMeIn? They use port 80 and 443, as we know. So how many exceptions do your firewalls actually have? And what are you doing about it? So I'm going to talk to you a little bit about a better approach to network security. It's called the software-defined perimeter. The software-defined perimeter is used to manage zero trust model. Okay, so you start, and this has come up, by the way, this was designed and documented by the Cloud Security Alliance. It was created and invented for a better way to manage your internal assets now that we can't depend on the four walls of the organization like we used to. Software-defined perimeter automatically assumes that no one is trusted. That's your zero trust model that I spoke of, okay? You authenticate before the connection. You do not connect before authentication. It's extremely identity-centric. You have to look at each person contextually, what it is that they're doing, what it is that they should be allowed to do, and allow entitlements that reflect that. So as a salesperson, if I were a salesperson, then I would only have access to Salesforce, let's say, and maybe to a compensation system. I don't need access to a finance system or to configuration systems, okay? You also need a tool that's built for the cloud, that's stateless and highly scalable, because as we know, we add servers every day in the cloud. We do code changes rapidly, agile programming. I mean, I think I heard recently that companies like Facebook have something like 86 code changes a day, and all of them have to have the right security parameters inserted and supported. This is a very big job and a very serious one when you look at the breaches that are occurring. SDP compensates for TCP/IP's weaknesses. How does it do that? Well, the fact is that TCP/IP, as we know, is a connect, authenticate first and connect. This is just the opposite, right? All resources are visible. You connect, you authenticate. But the software-defined perimeter, you authenticate first and you connect second. So let's talk about that for a little bit, okay? If I'm going to, imagine that TCP/IP and the network is much like my grandmother in her living room. When Federal Express comes to the door, what happens? With TCP/IP, she might hear a knock. And TCP/IP would then, she'd say, hello. He'd say, this is Federal Express. She'd say, come in. All resources are visible. She's in there with your grandmother. The Federal Express is in there with your grandmother in the living room, okay? The opposite of that is the software-defined perimeter. What the software-defined perimeter says is that you have to authenticate before you come in the door, right? So she's going to hear a knock. Hello? It's going to be Federal Express. It's Federal Express. Oh, can I see your badge? Where's your truck? You know, the questions will be asked. We might ask something like, the system might ask, do you have the proper security software on your machine? Are you coming in from a rogue nation or from St. Louis, where you normally work? Then it allows you to connect. Once you're authenticated, you connect. And then only the resources that you're entitled to are visible. Remember what I said about a salesperson only seeing Salesforce. Okay, the rest of the network is obscure. The rest of the servers on the network are obscured. You cannot see them. So I can't lie in wait looking for the company jewels even if I get in and I'm not who I say I am, which the system should have caught. SDP has a rich policy language too, so it's very different. You have a lot of different options in which to. They all work normally in a grid mode, and you can ask many different questions. Should Jim have access to this server? If not, don't allow it. It depends, right? It depends. Is he contextually who we think he is? And if he is, yes, we'll let him in. And here are some of the various things that you can ask. What project is he working on, for instance? Is it the right time of day that he's usually in? Is there if he's a remote worker, is there an open service desk ticket? These are all parameters that you as a user should be able to enter in and then have the system. And there's many different tools that do this. We certainly have one at Cyxtera, but you can use different things to do this. Some work easier than others, but it's absolutely achievable today. We have folks asking us to put a list of biometrics against the system so that they can track who's going in and out of conference rooms. And if there are folks in the conference room that don't have security clearance to the highest level, then the highest level document could not be opened. There's all kinds of things you can do. So here we go, the zero trust security model. Zero trust has three core concepts. You want to ensure that all your resources are accessed securely, regardless of where they are. You want to adopt a least privilege strategy and strictly enforce it. And then you want to inspect and log everything for suspicious activity. It's very interesting in the logs what you can find, by the way. You will find many times that you've been protected really well with this kind of a posture. So let's look at them. The zero trust security model is a modern approach to network security. It restricts users to only what they're entitled to see. And then it default denies access for everybody, so that if someone should get your credentials, they are not allowed to see much. That lateral movement is eliminated. And also, one that we don't like to talk about much is the malicious insider. Sometimes anger makes people do crazy things, right? We know this. And in fact, if a malicious insider was actually gaining access to your systems, and it was in a zero trust model, they would still have minimum access to only the things that they were allowed to see. So essentially, we're segmenting, we're isolating, and we're contextually checking at all times. And then any communication, by the way, once you are connected, should be encrypted. So it's very important to implement a zero trust strategy, and the software-defined perimeter makes it easier to do. Once again, we talked about the firewall rules. If you were to write a firewall rule this way, it would require you to write a rule for every single person that would access your network and every single thing that they would do. It's almost impossible, but there's a lot of solutions out there that you could use. The software-defined perimeter was explicitly created to provide security across cloud platforms. I'm sure you've heard of SDN and SD-WAN and NFV, and those were created to provide orchestration and network management. They all have their place, but they were created for different things. Only the software-defined perimeter was created for security solutions. By the way, many of the SDN WAN providers use zero trust solutions to augment what they do. So together, they're extremely powerful. Here are some business cases that use zero trust and work very well, by the way. There's a remote user access. I mentioned this before. I think for years now we've been talking about Target, the original big breach we heard about, and the fact that how the bad guys access the PCI information in the stores was through, as we know now, an HVAC contractor. They were fixing the air conditioning systems, and their logins were not secure. Someone got a hold of the login. They hung around and waited and looked until they found the PCI system, and then they accessed it and they broke in. So the first thing we're trying to do here with zero trust is make sure that anyone using the system, especially remote users and especially those that aren't even part of the company, are isolated, and that they're doing exactly what they should be doing and no more. Why should a third party that has been hired to fix your Oracle database have access to your finance system, right? There's no reason for that. You can actually integrate some of these tools with a trouble ticket system. So then what happens is you get a ticket to fix an Oracle database, and the access is only given to the Oracle database. The individual fixes the problem, and then as soon as they're done, access is broken. They cannot hang around, they cannot lie in wait, they cannot, regardless of why they would do it, whether it's for a good purpose or a bad purpose, they are then ending access when they're done with their work. The access is ended. As you're doing hybrid cloud migration, imagine, everybody wants cloud first these days, right? They all want to, if not cloud first, they want to be on the cloud. They want to say that they're doing cloud things. But what we all know is that migration to the cloud doesn't happen immediately and instantly. It's a process that happens over time. So as you're doing this, imagine that once you set up Zero Trust, if you have the right tools and processes, when things are migrated, the same security parameters can be applied very easily and simply. Another use case for the software-defined perimeter is in the way of audit and compliance. Many audits require that you list and review everyone and everything that has access to certain servers. Imagine if you had a log that told you not just a VP on the VPN and IP address, but actually told you who it was and how long they were accessing and when they left. And then with mergers and acquisitions, we see this as a huge business case. So imagine one day, your company now has 100 new users. You don't know them. You don't know whether they're happy about this. You don't know what they have access to. We suggest you always start imagining that all of the users in your company, from your CEO down, are all have Zero Trust, and then add the entitlements in later as a way to protect yourself. So, software-defined perimeter in action. It allows you to secure your high-risk apps, your company jewels, as we call them. You can control your privileged users in a granular way, and also you can secure third-party access. You should be able to extend this to AWS and Azure and IBM and Oracle, all of the clouds that are out there, and Google, of course, and integrate native cloud features, because if you can't do that, once again, you won't be fully protecting yourself. And then lower the costs and simplify operations. I don't know about you, but in the years of the firewall, in order to make a firewall rule change and manage services that we were providing, we had to have one person make the change and another person to watch them do it, because these firewall rule changes were so critical to the business. Imagine having two people for every firewall rule, and imagine you had to write them for every single thing that every single person is doing. It would be impossible. So we're going to show you some Zero Trust in action. Remember these concepts. Whoops, excuse me, let me go back here. Ensure all resources are accessed securely regardless of where they're hosted or accessed. Adopt a least privilege strategy and strictly enforce access control. And then inspect and log all traffic for suspicious activity. SDP creates this secure network segment of one for every workload on your corporate network, as we've discussed in the last 20 minutes. SDP uses multiple integrated identity solutions to enforce this least privilege and then give strict access controls. And then it also records all the traffic and integrates with corporate SIEMs for complete enterprise security. A single point solution for zero trust that is identity-centric and network enforced is necessary. So how would it normally work? Just as we've talked about, you have someone that needs to access a system. They only access what they're allowed to. You have a remote user. They securely connect. They use multi-factor authentication perhaps, and we ring fence them. You have a privileged user. Let's say this is an IT admin. He also has multi-factor authentication. Maybe the multi-factor authentication and the service desk ticket are connected to the system too before he's allowed to access. It's checked. And then even server to server, we have to remember now in the world of IoT and machine to machine and AI, we have to remember that it's not all just about the person, right? So machines are talking to machines now, and we have to consider that as well. We have to remember that server to server access, either between locations, in the cloud or on premise, should also be identity centric and policy based. The IoT device to server should have fine-grained access control and validate the device. This would eliminate some of the breaches that we've heard about recently, where devices have not been updated, they have not been checked, and then they provide an entry point to the bad guys or the bad girls, right? So in summary, zero trust is an important technology and market trend. There's a lot of marketing noise out there, but really the basics of it are simple. Zero trust means you're only allowing your company, trusted individuals, to do things that you want them to do, and not everything. They don't have access to everything. You imagine that everyone is on the blacklist, and then you slowly give them permissions and entitlements. And then a software-defined perimeter architecture is the right way to achieve it. Because if you don't get granular and you don't look at all of the various ways that people are accessing the system in the cloud, software as a service, and so forth, you'll never get there. I like to talk about our networks today as being Swiss cheese. They really are. There's holes all over them. There's multiple ways that we can be breached. And so I hope today I've given you some ideas on which to protect your company. If you'd like more information, you can come to Cyxtera.com. And then finally, a reminder in honor of Cybersecurity Month, make sure that you isolate those IoT devices, those little devices that carry so much valuable information on them. Very, very difficult to update in some cases, and make sure that they aren't breached. And so at least putting them on a separate network will protect you in a better fashion. Thank you very much.